Hey everyone, my name is Peter Muhaya. I create math content that is short and easy to understand, that explains basic math concepts ranging from numbers to probability to statistics, calculus, and even geometry. In each video, I always try to start off with giving the definitions, and then later on I use examples that range in difficulty, and then I finish off every video with some independent exercises for you to try and with answers. If this is content that you find interesting, then please make sure that you subscribe to the channel, like this video, and also share this video with a student that could benefit from this content. In this video, I'm going to share with you how to multiply matrices, how to check if two matrices are compatible, and then multiply them. Now, if this concept is too challenging and you want to learn a little bit about the basics of matrices, then click on this link up here and watch the first part of this series where I give you the definition of matrices, check the order of a matrix before you can multiply or add with another matrix. With that said, and let's get started. So when you want to multiply matrices, the first thing you need to do is to check the order of a matrix. So from the last video, the order of a matrix is the number of rows and columns, and it's written as R by C. So R stands for the number of rows and C stands for the number of columns. So before you multiply, you also need to see if the two matrices are compatible. So the columns of the first matrix should match the rows of the second matrix. So here I used this short form here to be able to help you easily see how they're compatible. So R1, C1, this represents the order of the first matrix. R2, C2 represents the order for the second matrix. So if the two matrices are compatible, you only need to check the middle two numbers. The columns for the first matrix and the rows of the second matrix, those two numbers should be the same. If those two numbers are different, then the two matrices are not compatible and you cannot multiply them. But if they are compatible, then all you need to do is to take the number of rows from the first matrix and the number of columns from the second matrix, and that will give you the order of the final answer. So let's take a look at these two examples here. The first example, I have a matrix that is a 2 by 2, and I'm multiplying by a matrix here that is 2 by 1. So if you forgot how to check the order of a matrix, you only need to remember the first number represents the number of rows and the second number represents the number of columns. So this is a 2 by 2 and this is a 2 by 1. So you'll see here the two numbers in the middle are the same. So that means we can multiply those two matrices. So the final answer for this product is going to be a 2 by 1 matrix. The second example here, we have a 2 by 1 matrix and the second matrix is 2 by 2. So are we able to multiply these two matrices? The answer is no, because if you look at the columns from the first matrix and the rows of the second matrix, those two numbers are not the same. That means they're not compatible and you cannot multiply them. So let's go through a couple of examples where we're going to be multiplying matrices. So in the first example here, I'm going to be multiplying a 2 by 2 matrix by a 2 by 1 matrix. If you forgot how to tell how many rows and columns it has, the first number always tells you the number of rows. So horizontally, you count how many layers horizontally. And then the second number tells you columns, how many numbers vertically. So how many lines vertically. So the first matrix here is 2 by 2, the second one is 2 by 1. So are these two matrices compatible? Yes, because the numbers in the middle are the same. So the final answer here should be 2 by 1. So now let's see how we multiply them. So we're going to be multiplying -3 times 3 and we get -9. And then we need to add the product of 5 times 4. So we multiply -3 times 3 and 5 times 4. So when you multiply those two numbers like that, -9 plus times 2, now we also multiply -2 times 3, which is -6, -2 times 4, -8 times 4 is -32. So now we're going to add negative 9 plus 20, which is going to give us negative 11. And negative 6 minus 32 is negative 38. Now, if you look at the final answer here, you'll notice that it's a 2 by 1 matrix, just like we had predicted. In the second example, the first matrix is 2 by 1. There are 2 rows and 1 column. And the second matrix is a 1 by 2. 1 row and 2 columns. So now we look at the two middle numbers that are the same. That means they're compatible and we can multiply them. So the final answer is going to be a 2 by 2 matrix. So how do we multiply a 2 by 2 matrix? We're going to multiply 6 times 5, which will give us the first number, negative 30. And then 6 times 4, which, negative 3 times negative 5 is positive 15. And then we multiply 6 times 4, which is 24, positive. And then negative 3 times 4 is negative 12. And this will be the final answer. It's a 2 by 2 matrix, just like we had predicted. In the final example here, we have the first matrix. It's a 3 by 1. There are 3 rows and 1 column. And then the second matrix is a 1 by 2. 1 row and 2 columns. So that means our final answer is going to be a 3 by 2 matrix. So now we can go ahead and multiply. Negative 5 times 3 is negative 15. And then we can multiply 6 times 3, it's 18. 0 times 3 is 0. And then we repeat the process with negative 5 times negative 1 is positive 5. 6 times negative 1 is negative 6. 0 times negative 1 is 0. And that's it. So our final matrix here is a 3 by 2, just like we had predicted. So now that after going through 3 exercises, here are some independent exercises that you can try on your own. Calculate the product of the matrices, and if you cannot calculate it, write undefined for the matrices that cannot be multiplied. That means they're not compatible. Pause the video here, and after you finish doing the 3 exercises, you can unpause the video and I'll reveal to you the answers. Good luck. So here are the answers to the 3 exercises. In the first matrix here, we have a 2 by 2 matrix times a 2 by 1 matrix. So that means the answer is going to be a 2 by 1 matrix. In the second exercise here, we have a 2 by 2 matrix times a 2 by 2 matrix. That means the answer is supposed to be a 2 by 2 matrix. In the third exercise, we have a 2 by 3 matrix times 2 by 3 matrix. You'll notice that the number of columns from the first matrix are not the same number of rows in the second matrix. So that means they're not compatible. So this product is undefined.